today we're going to look at Lewis structures, which we talked a little bit about last time, but you're going to learn how to actually create them yourself this time. Okay, so we're going to start by identifying how many electrons atoms need to gain in order to become noble gas-like or full octet. So if we look at carbon here, carbon has 1, 2, 3, 4 electrons. It needs to gain 1, 2, 3, 4. Oops, let me get my pen working. Needs to gain 4 electrons in order to get a full octet. Okay, let's take a look at nitrogen. Nitrogen has 1, 2, 3, 4, 5. It needs 3 more, 1, 2, 3, so it's going to gain 3 electrons. And then oxygen has 6 valence electrons. It needs to gain 2. Okay, so this is a good hint for us on how many bonds each of these atoms typically will form. Carbon will form a bond here where it shares with another electron, 2, 3, 4, 4 here. Nitrogen, 1, 2, 3, 3 here, and oxygen will form 2, 1, 2. And hydrogen, we didn't have on the list, but hydrogen will form 1 bond because it needs 1 electron. And sometimes we call this the honk, H, 1, 2, 3, 4 rule. So hydrogen down here gains 1. Whoops. Go away. Okay. Hydrogen gains 1. Oxygen has 2 bonds. Nitrogen has 3 bonds. Carbon has 4 bonds. Okay. This is what happens on simple structures. Hydrogen has 1 bond. Oxygen 2. Nitrogen 3. Carbon 4. Okay. So let's take a look here at identifying how many valence electrons each element has. So what I've done is I've taken this periodic table we were looking at the last podcast, and I just shrank it down to the first 3 rows, right? First 3 rows, and I'm just looking at the S and the P block, just those that have valence electrons, right? So I've compressed that here. This is the S block, and this is the P block. Okay. So what we notice is that everything in the first group has 1 valence electron, right? Everything in the second group has 2 valence electrons. Everything in group 13 here, starting with boron and then aluminum, has 3 valence electrons, right? 4, 5, 6, 7, and of course these are the noble gases where they have 8, unless of course they are helium and it has 2. Okay, so in order to draw Lewis structures, we have to be able to identify how many valence electrons atoms have. So remember, it's 1, 2, 3, 4, 5, 6, 7, 8. Okay, let's go ahead. So let's draw the electron dot structure for fluorine. So remember, electron dot show just the number of valence electrons. So we've got fluorine. Fluorine is right here, okay? So it's got 1, 2, 3, 4, 5, 6, 7 valence electrons. We're going to draw it just like that. 1. Remember the school bus rule? Take single seats until they need to double up. That's 4, 5, 6, 7. That's the electron dot structure for fluorine, okay? We want to do the same thing for phosphorus. Phosphorus is right here. It's got 1, 2, 3, 4, 5 valence electrons. 1, 2, 3, 4, 5. So the question here is how many bonds will they each form? Okay, so fluorine has 7 valence electrons. It needs 1 more, so it's going to form 1 bond, right? Phosphorus has 5 valence electrons. It needs 3 more, so it's going to form 3 bonds. 1, 2, 3. See how that works? And that's generally true. There are some exceptions, but that's generally how many bonds it will make. Okay.